Hey, welcome to the Lux channel. So often whenever I shot video episodes on networking, protocols as well as network software development and as well as networking concepts, I always suggest you guys to use tools like Wireshark, including whenever you do even socket programming like user space socket programming, you can use Wireshark. There are also instances even if you do some kernel level development in the user space, you can monitor the flow of packets and stuff like that using Wireshark. So along with that, I also a couple of tools I have suggested down the lane, and one such tool very useful in terms of network administration, as well as in case if you are a network software developer, or else even if you are a network security architect or something like that. There's a tool called iPerf. It is really versatile and it is useful. There are few things whatever an iPerf can do. In fact, you can write a very simple code and you can do yourself, but iPerf does everything for us with few options. You can use it for some kind of TCP testing, UDP testing and stuff like that. So it's quite interesting using something like an iPerf platform. So you can run it on a system, and you can make an iPerf server instance running on the same, and it listens to the same, and then you can run it in another end as a client, and then you can just connect to the remote iPerf server and you can just send data and you can analyze. So here is a catch. Apart from using it as a tool to do some network monitoring and analysis, there are also companies sometimes they use iPerf as a kind of as a benchmarking tool or something like that, or else apart from that they can use it as a stress testing and stuff like that. So there are various applications. So I have seen even companies who do VPN product offering, they even give some iPerf benchmarks and stuff like that. So this is something sort of misleading. I highly recommend whenever you do such claims, you should bear in mind iPerf just going to send you some synthetic data. It is going to send some numbers 0 to 9 and sequence of this data, nothing else it is going to send. Whereas if you see a real world data, it is going to be a lot more discrete and it is going to be different. So this is something is kind of misleading. I have seen literally some product companies use iPerf as some kind of benchmarking and stuff like that. So you can use it as your unit level testing, you can use it as your system level testing, but don't ever claim a product with some iPerf benchmarks and suggest that product is capable of something in front of your customer. So that's what I can suggest at this point. So if you dive over here, I have installed iPerf in my Ubuntu system. You can just run iPerf. You can see here, you can type --self and it shows all these options. So today I can show you a very quick demo of iPerf TCP and UDP as well as some kind of usage of iPerf in a real world testing scenario. So it's quite simple. You can just do iPerf -s. You don't need to be a super user or something, because this is just a simple user space programming, socket code essentially iPerf uses in the backend. So you can use it as a normal user. You can see here it listens in the port 5001, so that's the port it is listening. And if you don't mention as UDP, you can see here you can mention as UDP. If you don't mention as UDP, it default listens on TCP socket. So in the remote end, you can just do an iPerf and you can mention as client, because this is a client whereas that's a server, and you can mention 127.0.0.1, and once you do that, it is going to send some bulk data from to and fro, and then it gives you that core performance of that data transfer. So before running the client, you can also do one thing is we can run Wireshark so that we can capture the data transfers. So sudo Wireshark. since it is on localhost, you can see here I am typing as localhost. If you are doing it within two systems, two individual systems, of course you can mention its IP address, the port IP address, whereas in this case I am just going to show a very quick demo, so I am not bothered about it. So you can capture it in localhost, and then we can get back here and we can run the same. So it is going to send some amount of data and it is going to come out, and this is what something you can highly customize. You can give your own options and stuff like that. And here is where I would like to recommend for every test, don't use ping or something and ping packet manipulation like X amount of bytes, and then just don't take ping alone, because ping is not like the TCP streams. It is not that useful whenever you are testing really like very sparse networks. You need some sort of TCP kind of characteristics. Ping more represents a UDP like flow, because it is not having any connection and it is not like a stream which it can be regulated and stuff like that. So use an iPerf tool so that you can test TCP connections. You can do also multiple iPerf and then you can test the same. So you can see here, since it is on localhost, it is directly happening from the user space. It goes to the kernel space, and kernel space again back to the user space, and since it is going to be much faster than you do it from one system to other system, it is giving us this performance 47 gig, and in this case it is overall it is showing 40.7 gigabits per second. So this is quite interesting. If you have some other computer, if you have Raspberry Pi or something like that, you can even use it like a sort of benchmarking tool, because this is going to give you a sort of accurate version of how much that particular system has that potential. So if it can transfer it to 40 gigabits per second, you can of course install a 10 gigabits per second NIC card and it is going to work fine. But in case if you have some Atom processor or some kind of SoC, and if it is giving us around 500 Mbps or else at the max 2 gigabits per second, in that case there is no point of you installing some 10 gigabits Ethernet card. So this is what it is going to give us a very good picture. And meanwhile we can get back to Wireshark. Let me just stop it. You can see here we can filter all this 5001 port transfer. So you can see here this is the iPerf data. You can see here it has this sort of a pattern. It just sends this data bytes. You can see here it sends this printable characters 0 to 9, 0 to 9, 0 to 9, and it is going to repeat the same. So nothing much happens. So this is the reason you should not use iPerf as some kind of product benchmarking to claim that your product is doing something in terms of real world use case. So iPerf is really sending this repetitive repeating patterns. So that's about it. It is not sending anything like a file or something. So nevertheless it is quite useful, as you can see here. So with this we can confirm that it works, and we can also do one more thing. Like I said, we can cancel this session and we can also make it to listen on UDP port. So -u. So this makes it to listen on UDP port. You can see here it is listening on the same port number, but this time on UDP protocol, UDP transport layer protocol. So we can go back to Wireshark and once again we can reinitialize this capture, and we can go here, and for the client part you can just mention as -u again. So this will make it a client as well as server to communicate in UDP transport layer protocol versus TCP. So once you do the same, UDP happens a little bit in a different rate rather than TCP. You can see here the inflow of packets, it is happening at much lower rate than TCP. So you can see here the overall transfer rate is around 1 Mbps or 1.25 Mbps. It is not that fast as TCP. It's just I think you can adjust its parameters and you can adjust that frame rate and stuff like that, whereas TCP is like an entire stream or an entire connection. So that's why they have kept it in that way, so that it just does that bulk transfers and it analyzes that channel performance. So iPerf, trust me, Cisco extensively uses iPerf whenever they take new server, not a server, whenever they take a new hardware along with a new ported Linux OS on top of it. Cisco uses extensively iPerf benchmarks. I even when I was working in Monta Vista, we used to get some complaint from Cisco saying that so and so SoC with so and so version of Monta Vista Linux have some issues in performance when they tested with iPerf. So this is a common thing in the networking world. They use iPerf really to test the channel performance. The entire objective is to test channel performance, because each time you can't take one file and then somebody tests with some set of files and you test with some other set of files with some FTP or HTTP or some sort of download. So iPerf is a cool tool to use rather than using something like that. So here is a catch. Why iPerf is really useful for network security experts is you can do stress testing, you can do some kind of bandwidth saturation and stuff like that. Imagine this iPerf is happening between one system to other system. You can saturate that link and then you can see how it is affecting the performance. You can do some kind of DOS attacks and stuff like that. So iPerf is very versatile. It all depends how you kind of use it, because this is where you can do a simple socket code and you can do something like this, but you have a tool like that which as it is you can customize and you can use it for your applications. So you can see here with this we tested both TCP and UDP. So this is one simple case. I don't want to give something like this as an example. Let me give a real real world example so that you can understand its true potential. So in terms of real world application, what I have is I have this entire my VANOpt systems ready. Everything is a VM in this system. Everything is a VM. As you can see here, there are many VMs over there, and in that I just running this VM. This contains the Toffee data center WAN optimization device. The entire build and entire test machine is this, and this is its clone, and you have this test desktop and you have this pfSense router. So essentially everything is connected one after another. So this really mimics a real world deployment or a topology. So if you come here, you have this system. So let me just keep the GUI ready. Yeah, you can see here not much is happening because we are not sending any data, and this is the other system and this is the test desktop. So before doing that, we can capture once again as a iPerf in the desktop, in this Ubuntu host machine in TCP transport layer mode, and we can hop onto this desktop and then we can initialize an iPerf connection to that remote TCP port. So iPerf -C 192.168.0.88. so that's the device versus this is this test VM. So this you can see here, this is in the subnet 192.168.0/24. This is the subnet. It is getting via DHCP from my pfSense VM router. So that's what it is. And this is the IP address of this host machine where all these VMs are installed. So if I do the same, you can see here it has initialized that iPerf connection, and I have set some parameters in my VANOpt doing some packet rate limit and stuff like that. So we ignore the performance degradation of iPerf and stuff like that, because this is not about WAN optimization. I'm just showing a very quick demo how it can be used in a real world scenario. So you can see here it has sent around 100 Mbps speed, which is close to 100 Mbps. You can see 92.2 Mbps. And if you hop onto this device, as you can see here, you have this packet transfer. So this this kind of asymmetric graph, it tells me that there's a lot of packets got optimized as a part of its WAN optimization. You can see here, this is the WAN to LAN. You can see this is in Mbps, capital M is in Mbps. It got this peak curve, and then it got optimized, and it has sent very less packets, and the amount of packets are also reduced, the amount of data is also reduced in each packet. So this is about WAN optimization. Let's not get into that. So before I conclude, I would like to also mention, if you do a man page of iPerf, you can see here it has some interesting options which you can explore. It has this interval option, like it mentions pause n seconds before periodic bandwidth reports, and apart from that, you can also change its listening port, which is quite handy because you can listen multiple instances, and you can test multiple such connections. So apart from that, it has this interesting option. There are certain TCP options. You can see here it has this MSS which you can set or which you can change and customize. And other than that, it has this let's take another example. You can also change other parameters like -n and stuff like that. It is quite handy whenever you do such extensive tests. So this is with iPerf extra options, and there is an option which you can even use to prolong your test by increasing the duration, or else the number of bytes as well. So let's see, we can use this option -n to transfer much more data than what it has transferred. So -m, capital M is for megabytes. So we can do one thing, we can just run this -n, so 400 MB. So we can mention something like that, so that we can saturate this link and we can extend this graph. See, what I'm worried is it has this, once again, if I run the iPerf, it came here, and obviously you can see there is a lot of data being pushed from one end to the other end. That is the reason it is reflecting here, but it is not reflecting, because the other end to this end, it is only getting, in the case of TCP, it only gets a TCP ACK packet. So which is why you don't get much here. It is just in the form of a few KBs, whereas in this case it is several MBs. You can see whenever such spike occurred, it is several MBs. Okay, so that's what it is. So we can transfer much more data, and we can analyze for some time, if you leave the channel open, how it behaves. So now I'm running with 400 megabytes, so we can just wait some time, and we can capture over here. So once again, my main emphasis is just not about, I can do a very quick video about how iPerf work, and this is something you get anywhere in the internet. There is no fun about it. I need to show in real world situation how it can be extensively used, both in terms of unit level testing and as well as performance analysis, as well as debugging your networking appliance or some network software, like in my case. So yeah, you can see here now it is even more saturating the link to the fullest extent. Unlike over here, you can see here it has peaked all the way up to 114 megabits per second since it has got optimized, because the WAN optimization is active and it is enabled. The entire 114 megabits per second is converted into just 5 megabits per second. So that's the main advantage of using Toffee data center. So imagine you send an iPerf data iPerf test with some kind of 3G connected network. So if you don't have Toffee data center and if you connect a PC with some 3G dongle and or 4G dongle, and then in the remote end you test some server, you can definitely see the performance curve. So instead of sending 114 megabits per second, it is going to optimize, squeeze all the data, and it is going to send at just 5.76 megabits per second. And one more thing is, this is not something, like I said before, this is not something you should take too serious in terms of optimization, because this is not any real test scenario or real usage, because this is just a synthetic data which contains series of numbers. So that's what it is. So nevertheless, I can test my tool whether it is all working fine. I can do even some kind of burn testing. I can automate several threads, and I can test continuously iPerf running for 6 hours, 10 hours, 12 hours, and I can test whether the device and the software is stable enough so that it can have certain criteria like a carrier grade equipment. So that's what. So you can see here the test is complete, and this time it has sent at a much higher rate. You can see 400 megabytes. Not rate. It has totally transferred 400 megabytes, and its bandwidth is at 101 Mbps. So you can see it again matches this bandwidth overall. It is here 77, whereas here 101, and here it has transferred totally 92.2 bytes, whereas in this case it has transferred the set 400 megabytes. So that's what. So like this it can be used. I even used once iPerf for my Toffee Mocha as well, so that I can do some rate limit, I can introduce some jitter, I can introduce some packet corruption and stuff like that, so that it mimics a real world situation like satellite links and mobile links and stuff like that. So you can see there are various applications with iPerf. A tool like iPerf in a real world situation, it can be used for developing VPN setup or VPN software, or it can be used for any network appliance to test how the appliance is performing with various loads, and especially a synthetic load which you can repeat again and again with a tool like iPerf. The reason is, when you do file download or something like that, each time something can change and it may differ each time whenever you do that, whereas iPerf gives that real unit level testing scenario where you can even more automate and make it precise. You can do each time the same level of steps repeated for every test. So this is quite useful, and this is the main reason iPerf is quite interesting to use in a real world scenarios whenever it comes about network software development, or else if you are a networking systems admin or something like that, you need iPerf to test in case if there is some bandwidth issues you are facing, or some kind of broadcast from, or some kind of networking issue, and you need to check your channel beyond just using ping command. You can use something like iPerf. You can test UDP performance, you can test TCP performance, and you can assess the channel performance before any problem occurs, and while it has got some problem, and after you mitigate and after you solve and fix the issue, and then you can again run the trials, and then you can find it out it has eventually been addressed. So this is also one case. And as I said earlier, there is another situation. If you are a network security expert, iPerf tool you can creatively use, because I can't say you can use as it is. You need to creatively use, and you can initiate some kind of DOS attacks. You can do some some kind of network channel saturation and stuff like that. So this is somewhat related to my couple of episodes. I discussed one episode about networking device buffer bloat, and recently I shot an episode on networking device or network appliance tail drop. So in these kind of cases as well, you can use tools like iPerf, and you can suddenly do some kind of you can introduce a bursty traffic, and then you can see what is happening in that specific moment. So again, you can do not iPerf just with one system, you can do with multiple systems, and at the remote end with multiple iPerf listening servers, and then you can just do some kind of stress level testing, and you can see whenever the tail drop happens, as it gets saturated. And at the same time, you can even do scenarios like buffer bloat, because it is going to pile up the packets and it is going to affect the network device performance when it occurs, the buffer bloat occurs. So these cases, it is interesting to use tools like iPerf, and if not iPerf, of course you can do some kind of custom socket code, but you can use iPerf as it is. So that's about it, guys. Like I said, this is really being used extensively in the industry, and iPerf is a very good tool whenever you want to evaluate a new Linux ported operating system. Please understand, here is where I need to mention it in double quotes. Like I said, Cisco's case, when they get a new hardware, it may have new Linux ported on that hardware. It's a custom Linux OS or a Linux distribution for that hardware. So they test the OS capabilities, the Linux kernel's customization, kernel tune-up using iPerf, especially the kernel's networking subsystem using iPerf. At the same time, they also test the hardware capabilities, because they are also getting a custom hardware as well as a custom operating system for that hardware. So they also test the hardware capabilities, a tool like iPerf, whenever they get it from third-party vendors. So that's what it is. So hope you guys loved watching this video. If you have anything to discuss, as usual, be in touch via mail. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.